guys, welcome to the lesson. It's Pythagoras' theorem again. We're going to show how Pythagoras' theorem can be applied to everyday problems. So let's crack on and get the job done. In example 1 then, we have an isosceles triangle. And the property of an isosceles triangle that you must be aware of is if you drop a perpendicular from the vertex to the base, i.e. at 90 degrees, it splits the base exactly in half, and that's key. Now we only need the right hand side of the isosceles triangle in order to find x, and the reason we need to find x is because the area of the triangle is half base times the vertical height, where x is the vertical height. So using Pythagoras on that right side triangle, the yellow triangle, 8 squared equals x squared plus 3 squared. Subtract 3 squared from both sides, and then we square root. Now, in order to find the area of the triangle, we're going to use half the base times the height, and remember the base is 6 centimeters of the isosceles triangle. So it's a half times 6 times root 55. Tap that in our calculators, and we're rounding off in this case to 3 significant figures. Here in example 2 we've got compass points, and bear in mind with these the compass directions that will be given to us will always be at right angles to each other, because we need a right angle to apply Pythagoras' theorem. So a ship S sails 40 kilometers due south from a port P. So due south would be in that direction and label the 40 kilometers, and from there it changes direction and sails due east 60 kilometers. So the diagram would look something like that, and now we want to find the distance of the ship S from the port P, which would be that distance there, which I've labelled D. So using Pythagoras' theorem, d squared equals 40 squared plus 60 squared, that's 5,200. We square root both sides, use our calculator, and then round off to 3 significant figures in this case. In example 3, we have a ladder which is leaning against the side of a house. The base of the ladder is 0.7 meters from the house, and bear in mind that we'll assume that the ground is horizontal, that the wall is vertical, so there's a right angle between the wall and the floor. We've got a distance of 0.7 meters because that's the distance of the foot of the ladder, the base of the ladder from the wall. The ladder is 3 meters long, and we want to find how high up the side of the house the ladder reaches, and that's a distance marked on x. So using Pythagoras, 3 squared, this is the hypotenuse is 3 squared equals x squared plus 0.7 squared. We subtract 0.7 squared from both sides. That gives us 8.51. We square root, use our calculator, and then we round off, in this case, to 3 significant figures. And finally, example 4, find the distance between 2 coordinates. Absolutely key. We must draw the diagram, so a little sketch of where those coordinates are. And when we draw the diagram, -2, -1 would be there, which I've called point P, and 3, 4 would be there, which I've called point Q. Now, to get from P to Q, in order to give us a right angle, we can go straight up and straight across. And if we count squares up, it's 5 squares up and it's 5 squares across. So now we want the distance PQ, but we've got a right angle triangle. So d squared equals 5 squared plus 5 squared. That's 50. We square root both sides. We get our calculators out, and then we round off. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.